So I'd like to spend a little time in this video talking just kind of very generally about chemical reactions, and just giving you a quick overview onto the types of chemical reactions. So before we get into it too much, I've got some examples up here that we're going to walk through and kind of talk about. Let's get some of the basics out of the way. So when you see a chemical reaction in chemistry, right, the great signifier of that is that arrow, right? That arrow is what shows you what separates the left from the right, and in chemistry terms, what separates the reactants from the products, right? And the reactants being the things that we take physically and put into the mixture, put into the beaker, put into the flasks, mix up real good, put some water in there maybe. All those things that we are mixing together are the reactants. They go on the left. The things that we are producing on the right are the products, right? So it's like a left and a right, reactants, products, even a before and after. The other thing that's good to point out while we're here is that there are some chemical reactions which we say are reversible. So what that means is that the reactants, let's get my eraser out here just so I can kind of talk you through this a little bit. So my reactants will, and back to my pen, turn into my products, and my products might feed back and turn into my reactants, right? It's kind of a weird thing, but they're reactions that go both ways. So sometimes you'll see reversible reactions, and if you do, you'll see that by seeing kind of a double-sided arrow. Just means that, yeah, those reactants will turn into the products, but yep, those products are going to react and they're going to turn back into the reactants. So with that said, let's jump in and talk about the examples of, clear myself a little space, types of chemical reactions that we have above. So if you look, right, I've got 4 things: synthesis, decomposition, single replacement, and double replacement. And the truth is, just about every kind of chemical reaction, just about, probably 95% of them, fits into one of these 4 categories. This is kind of the big 4 categories. So in this notation, right, A's and B's are representing positive ions, and X's and Y's are representing negative ions. So keep that in mind. Right, so we'll run through what each reaction is and just kind of talk about each one fairly briefly, just give you a quick overview. So a synthesis reaction up in the upper left here, right? Some people also call this a composition reaction, right? So the idea here, this is your typical like make an ionic compound kind of reaction. You've got a positive ion and a negative ion, and they're going to come together to form one compound. Great example of this is the reaction of hydrogen gas and oxygen gas. Is actually kind of a neat little reaction you can do, because it will produce, if you give it a little zap, H2O, right? So see what happens. Hydrogen's kind of your A, oxygen's your X, and they mix together and form one substance. We also have below that your decomposition reaction. So your decomposition reaction is the exact opposite of a synthesis or composition reaction. You're taking one thing and you're breaking it apart into 2, right? So this would be if we took water and added some energy to it and turned it into those 2 gases going kind of the other way. In the upper right, you have a single replacement reaction. So single replacement reactions are getting a little bit more complicated, but they're not too bad now. So you have one thing, AX, so again, remember our ions. This is typically a positive and a negative, and a B is also typically a positive, right? So it's going to do exactly what it sounds like, single replacement. The like ions are going to replace each other. So this B is going to scooch in and force out that A, and then on the product side, we'll have BX and A by itself. Good example of this is if you mix an acid with zinc metal, right? The zinc is a positive ion, the H is a positive ion, so what you'll end up with on the other side is zinc chloride and hydrogen gas good time for me to point out that none of these green example reactions that I'm doing are fully balanced equations right now. They're just real quick examples, right? So again, you can see it. Your H is kind of your A, your Cl is your X, your zinc is your B. So then what do you get on the other side? Well, you get Bx now, not as opposed to Ax, and the A is off by itself. Double replacement is the most complicated one that we talk about here. Clear a little bit of space just before I get into them because it is a little bit more writing. I'm actually going to get rid of the decomp part here too, so I can kind of write it next to it. There we go. So in a double replacement reaction, it's kind of like, go back to my green, I like that the pop. Oops. There we go. A double replacement reaction is going to be kind of like a single replacement, but with just more of it, right? We're going to have more replacement going on, twice as much. We're going to have double replacement. So let's see, what's a good example of this? We can take sodium hydroxide, NaOH, and we can add it, my H, to copper sulfate. Actually, let's do copper chloride. And then we will produce sodium chloride and copper hydroxide. So I got a little bit small there, but hopefully you can still see it. So sodium hydroxide would function as your A. Let's switch colors so it shows up a little bit better. So sodium is your A, the hydroxide is your X, the copper, the Cu, is your B. The chloride is your Y. So then you don't get to switch the designation. Sodium is now forever A, and so on and so forth. So on the product side, you get sodium as your A, chloride as your Y, so you got AY, and then you've got copper hydroxide, so you've got BX, right? So this clearly matches this form, right? And I think you've kind of probably noticed by now, these reactions will fall under one of these four categories. So this is decomposition, which I erased, single replacement or double replacement, but it's not always quite so straightforward as just A's and X's, right? You see things like the 2's, you see things like the parentheses, the polyatomics, things like that. So you can't get too regimented and just looking straightforward for single ions and single substances and simple straightforward A's and X's and B's and Y's. You have to be prepared to kind of analyze it a little bit more deeply, but they will fit into, most reactions will fit into one of these categories.